A groundbreaking discovery has recently caught the attention of both scientists and space enthusiasts. Bill, a renowned science communicator, made headlines when he revealed that Voyager 1 had detected 300 large objects in space. This revelation has sparked widespread intrigue and raised many important questions about the nature and origin of these objects. What are they, and where did they come from? Join us as we dive deeper into the mysteries hinted at by Voyager's initial findings. For nearly half a century, the Voyager missions have delivered some of the most extraordinary and early glimpses of the wandering bodies in our solar system. Surprisingly, these missions were not designed to endure for this long. Back in the 1970s, Michael Minovich proposed an innovative idea. Spacecraft could harness a planet's velocity to propel themselves deeper into space. Initially expected to last only 5 years, the Voyager missions have far exceeded these expectations. Launched just weeks apart during the summer of 1977, Voyager 1 and Voyager 2 were originally tasked with exploring Jupiter and Saturn. They completed this mission by providing comprehensive data about these gas giants. However, the journey didn't end there. In 1986, Voyager 2 made history by being the first spacecraft to provide close-up images of Uranus, and 3 years later, in 1989, it did the same for Neptune. This monumental flyby of 4 planets earned the mission the title of the Voyager Grand Tour. Rather than concluding their journey, the spacecraft set their sights on a more ambitious objective: exploring deep space. Now, 45 years after their launch, both Voyager 1 and Voyager 2 continue their travels, sending invaluable scientific data from the farthest reaches of the universe. In 2013, NASA made an exciting announcement. Voyager 1 had officially entered interstellar space, the region between stars, beyond the sun's magnetic fields and influence. It was like stepping out of the busy solar system and into a tranquil, star-filled wilderness. This journey continued in 2018 when Voyager 2 crossed this vast expanse. Situated 17.7 billion kilometers from the sun. Remarkably, Voyager 1 and Voyager 2 remain the only spacecraft to have ventured into interstellar space, providing us with crucial information on how the interstellar medium interacts with the solar wind from our sun. These pioneering missions have served as our primary source of knowledge about the heliosphere, a protective bubble that shields our solar system from cosmic hazards. The heliosphere, shaped and influenced by solar wind, a constant flow of charged particles from the sun, acts as a protective barrier for our solar system. Both Voyager spacecraft have served as our cosmic messengers, sending back valuable data about this celestial shield. All this information converges at the heliopause, the outermost boundary of our solar system, marking the transition from the solar wind to the vast reaches of interstellar space. Thanks to the Voyager spacecraft, we've gained new insights into the properties of interstellar space. One significant discovery is the nature of cosmic rays, mysterious, high-energy particles that are far more intense beyond the heliopause than within the safety of the heliosphere. It's like comparing the calm of a quiet garden to the hustle and bustle of a crowded street. But this cosmic tale doesn't end there. NASA expanded its understanding by integrating data from newer missions with Voyager's observations, piecing together a more complete picture of how the sun interacts with the surrounding interstellar medium. In an unexpected twist, in 2023, Voyager 1 picked up a faint, low-frequency humming sound corresponding to vibrations in the small amounts of gas drifting through interstellar space. Nicole Fox, head of NASA's Heliophysics Division, emphasized the significance of these findings. Over the past 46 years, the Voyager missions have provided invaluable insights that have transformed our understanding of the sun in ways no other spacecraft has achieved. This incredible space journey is even more impressive when considering the Voyager spacecraft's power limitations. Both spacecraft rely on plutonium-powered systems, but as the plutonium decays, it generates less heat, gradually depleting the spacecraft's energy. To tackle this challenge, NASA has been forced to make difficult decisions, shutting down non-essential systems, including the heaters that help keep the instruments warm in the freezing void of space. Yet, despite these challenges, all 5 key instruments on the spacecraft have continued functioning since 2019, defying expectations. NASA scientists remain baffled at how the Voyagers continue to operate in such cold conditions, where other spacecraft would have frozen. This ongoing mystery adds another layer of awe to the legacy of these remarkable explorers, whose journeys continue to surprise astronomers and deepen our understanding of the farthest regions of our solar system. The heliopause, the boundary between the sun's influence and interstellar space, is not a static phenomenon. Instead, it shifts and forms unusual angles, leaving scientists both intrigued and perplexed. The idea that the heliopause could change shape isn't new. In the last decade, data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite, IBEX, has shown evidence of its shifting position. These spacecraft provide crucial measurements of the cosmic boundaries, even though they only capture snapshots of specific locations at particular times. Eric J. Saran, a space physicist from Preston University, shared his excitement in an email to Vice, noting that the IBEX satellite has been supplying valuable data that is helping scientists refine their predictions about the heliopause's future movements. What makes the situation even more intriguing are recent studies that have challenged long-standing assumptions. In 2014, the IBEX satellite detected an unusually brightening of energetic particles, hinting at irregularities in the heliopause. These anomalies didn't align with current models, much like an unexpected plot twist in a story. Researchers also observed a significant shift in the position of the heliopause over a short period, which might explain why Voyager 1 entered interstellar space in 2012, followed by Voyager 2 in 2018, despite the 6-year gap. These surprising findings challenge previous understandings of the heliopause, sparking debates among scientists. The search for answers is ongoing, and NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, set to launch in 2025, promises to uncover more secrets about the outer reaches of our solar system. Meanwhile, the mysteries persist. In May 2023, Voyager 1 encountered an unusual event. The spacecraft's Altitude Articulation and Control System, AACS, responsible for managing the direction of its high-gain antenna, began to send back confusing data. Instead of the usual health reports and scientific observations, it appeared as if Voyager 1 was struggling to communicate. It seemed to be experiencing something akin to electronic confusion, an issue akin to a malfunction. From Earth's perspective, it appeared that Voyager 1 was encountering electronic difficulties. The data it sent back seemed random and incoherent, as NASA described at the time. Interestingly, despite these unusual reports, Voyager 1 itself appeared to be functioning normally. Its radio signal remained strong and stable, indicating that the antenna was still pointing toward Earth, contrary to what the AACS suggested. Adding to the mystery, Voyager 1's scientific instruments continued to operate without issue, seemingly unaffected by the AACS malfunction. Even the spacecraft's fail-safe system, designed to put it in safe mode during problems, was not triggered. Fortunately, NASA quickly identified the problem. The AACS had been relying on a computer that had been inactive for a long time. The solution was simple. They sent a command to switch to a functioning computer to ensure the data transmission continued. However, the cause of the AACS's strange behavior remains unclear. NASA speculates that an incorrect command from another onboard computer might have caused the issue. Although this anomaly didn't jeopardize Voyager 1's mission, NASA continues to investigate to prevent similar issues in the future. Voyager 1 has been exploring interstellar space for over a decade now, far beyond the Sun's protective magnetic field. This field, similar to Earth's magnetic shield, acts like armor against cosmic rays and radiation. But like other spacecraft, Voyager 1's onboard computers occasionally face challenges from high-energy particles in space. These particles can interact with the spacecraft's computer chips, causing small memory errors that accumulate over time. Susan Dodd, the project manager for both Voyager 1 and Voyager 2, offered a broader perspective on these challenges, explaining that encountering such anomalies is expected, given the spacecraft's age. These missions have far exceeded their original lifespans, now navigating the unknown realms of interstellar space where radiation levels are high and no other spacecraft has ventured before. Nearly 50 years have passed since Voyager 1 and Voyager 2 began their historic journeys, crossing unimaginable distances and exploring the unknown. Despite their 1970s-era computers, which have only 70 kilobytes of memory, less than today's digital watches, NASA has kept these spacecraft operational. Just imagine the effort it takes to send software updates across such vast distances, ensuring these spacecraft continue their work. Keeping Voyager running is like providing cosmic tech support in the darkest reaches of space, billions of miles from Earth. These legendary spacecraft continue to cross significant milestones, offering profound insights into the mysteries of our solar system. Could Voyager 1 have found something alien? Let's pause for a moment to honor these trailblazing pioneers. The twin Voyagers are now drifting forever among the stars, each the size of a small car, representing the technological spirit of the 1970s. Despite their outdated systems, which are less powerful than today's digital watches and their analog TV cameras, the Voyagers have left an indelible mark on every planet they've explored. Through them, we've uncovered extraordinary details about the planets in our solar system. Jupiter, once thought to be a calm giant, turned out to be a world of extremes, featuring hundreds of violent storms, a glowing aurora at its north pole, and intricate rings. Saturn, once believed to have a few simple rings, was discovered to have thousands of delicate, intricate rings, some with bright structures previously thought impossible. Perhaps most astounding was the discovery of active volcanoes on Jupiter's moon Io and Neptune's moon Triton, where nitrogen geysers were seen erupting at near absolute zero temperatures. Perhaps most exciting of all is the possibility of extraterrestrial life. Two of Jupiter's moons, Europa and Saturn's moon Enceladus, are believed to harbor vast salty oceans beneath their icy surfaces, oceans that could potentially sustain life, making them prime targets for future exploration. One of the most poignant moments in the Voyager missions came in the early 1990s when the spacecraft took a final look back at our solar system at the suggestion of Carl Sagan. They captured the iconic image known as the pale blue, a view of Earth from over 100,000 times farther away than any human had ever witnessed. This humbling image serves as a reminder of our small place in the vastness of the universe. In 2012, Voyager 1 made history by crossing into interstellar space. Over 11 billion miles from the Sun, Voyager 2 followed in 2018. These spacecraft are now so distant that it takes 22.5 hours for a signal from Voyager 1 to reach Earth and nearly 19 hours for Voyager 2. They continue their journey, moving 3 to 4 seconds farther away every day. NASA's Deep Space Network, with tracking stations around the globe, ensures continued communication with these distant explorers, even as the Earth spins. As the Voyagers venture deeper into interstellar space, their signals grow fainter, like whispers amid Earth's noisy backdrop of radio waves. Despite this, they continue to transmit valuable data, a testament to the resilience and brilliance of their mission. The Voyager mission itself was born out of fortunate timing. Scientist Michael Minovich first discovered that spacecraft could gain speed from planets using gravitational assists. Later, Gary Flandreau demonstrated that a rare alignment of the outer planets in the late 70s and early 80s could allow a spacecraft to reach Neptune in 12 years instead of the previously estimated 30. NASA seized this once-in-a-lifetime opportunity, even though they were working with a scaled-back version of the Grand Tour originally envisioned for the outer solar system. Nearly 5 decades later, Voyager 1 and Voyager 2 continue to stand as humanity's farthest emissaries, unlocking the secrets of interstellar space. Their legacy will endure for generations, reminding us of the boundless curiosity and perseverance that drive us to explore the unknown as Voyager 1 and 2 continue their journey into the unknown. The significance of their data cannot be overstated. These spacecraft represent the farthest humanity has ever ventured, and with each passing day, they provide us with an increasingly intricate understanding of our solar system and beyond. However, their primary mission was never meant to last this long. Originally designed for a 5-year exploration, they have far exceeded these expectations, offering a rare, long-term perspective of deep space. These missions highlight the incredible resilience of human ingenuity. They not only serve as time capsules of technological achievements from the late 20th century, but also as crucial instruments that broaden our understanding of the cosmos. As they venture further, both spacecraft are providing invaluable data about cosmic radiation, interstellar magnetic fields, and the vast, largely unexplored environment that surrounds us. Each measurement, each discovery, offers vital clues to the universe's secrets. Despite the considerable distance and the challenges of maintaining communication with spacecraft that are now over 14 billion miles away, NASA's Deep Space Network continues to ensure that these probes remain operational. It is a testament to the foresight and determination of the teams that designed and launched these missions, as well as to the enduring legacy of space exploration. These spacecraft are helping us grasp the scale of the universe in a way we never could before, offering glimpses of space that would otherwise remain beyond our reach. As Voyager 1 and 2 move ever further from Earth, scientists continue to analyze their data, refining our models of deep space and improving future exploration techniques. These missions have already surpassed expectations in terms of both longevity and scientific contribution. Looking ahead, they are inspiring a new generation of scientists and engineers who will undoubtedly carry the torch of space exploration forward into the farthest reaches of the universe, hoping to answer the age-old question: are we alone in the cosmos?